Okay, so our last example, we talked about the CNN tower, right? And we were trying to figure out the differences where the pinnacle of the height was and where the restaurant was. And we did some basic trig, and then we subtracted different heights to figure out the difference of it, okay? So for today, let's talk about sailing and airplanes. Computing the bearing of an object. So what does that mean? The bearing from point A to point B is the degree measure of the acute angle formed by ray AB and the north-south line. This is really important. Okay? North-south line. You know what? It's so important, it needs another color. Deserves red too. Now, why is it so important? Because we have trained our brains to do reference angles, right? And reference angles was always the horizontal. The acute angle is formed from the horizontal line. This is the opposite. It's the north-south line, okay? So when we're making our acute angle, we're looking at the north-south line and seeing how far from it, degree-wise, we're moving, okay? So that's the big change. And you can really mess up your problem if you go the horizontal, so you don't want to do that. Let's put some examples underneath it. Let me show you what this means. Okay. So we have our coordinates, north, south, east, and west. Yes?
Yeah, is this where the
Oops, wow.
whole like
There's two souths.
bearing on a compass thing comes from?
That's what we're talking about. Yep.
Okay.
Mhm. So if I had just like this sort of general plot, and I want to go in a northeast direction, approximately 42 degrees, it would look something like this. Okay? And how do we write it? We write it as n, so either north or south goes first, the degree measurement, and then what direction, east or west. Okay, so that's northeast, 42 degrees. But again, we're doing it from the north-south line. I would not measure 42 degrees from the east line, okay? So if I were to try a different one, a different example, if I would go in this direction, that's, let's say this. Okay, so let's put the angle to be 72 degrees. That is a W, that doesn't look like a W. I can't write today. We can see that this would be north, 72 degrees, and then we're going in the west direction. Okay. Does that make sense so far? So it's north or south is the first letter, and then the degree that you're going in, and then is it west or is it east? Okay. Let me give you an example of one going south, so you can kind of see how that works out. So let's try this one. Okay. So if I were to go in the south direction, 69 degrees, and we're going east, I would write it as south, 69 degrees east. Okay? So there we go. Now we're going to use those to calculate position of whether it's an airplane, or it's a ship, or just some object. Okay, we're going to use these measurements to help find some values here. Now I'm going to use this picture to answer the following three questions, okay? So I'm going to draw the picture first. Let's see. point O in the middle at the origin. Okay, so there we go. Give you a chance to draw that. And here's the questions. So part A is going to say, find the bearing from O to C. Part B, find the bearing from O to B. And part C, find the bearing from A to O. Okay? So when it says that, I'm going to have an answer of like north or south, some degree measurement, and then east or west. Okay? Where is my letters? Wow. This is one heck of a Monday already. Okay, so let's give it a shot. So look from O to C. So here's O to C. Now remember, when we do bearings, we got to make sure it's the degree measurement from the north-south line. And we do have that measurement, right? So that's good. I don't have to do no calculation. So just 40 degrees here. Okay. So therefore, it's going to go south 40 degrees east. Okay. So that was good. All right. From O to B. So again, we want to measure from the north-south line. It'd be this degree measurement, right? But I don't have it. So I gotta do a little calculation. I know this first quadrant's gonna be 90 degrees, right? So if I take the entire angle measurement, which is 118, take 90 from it, that'll give me the angle I need, but I'm going from the north direction here, okay? So in parentheses, I'll just go ahead and put that. So it's gonna be the 118 minus 90, okay? So that's gonna equal 28 degrees. So now we know what that angle is. I could actually tell what the bearing's going to be. So it's going north, 28 degrees, and it's going to go in the west direction. So that one, just a little bit of calculation there. Now the last one, notice I switched it, right? O is no longer the starting point. It's now A, okay? And here's what I'm gonna do. I'm gonna redraw, because I don't have much space here. I'm gonna redraw this picture down here and show you how do you go backwards, okay? So let me just do a quick sketch. So here's A, 22 degrees, okay? And what you're gonna do, let's say there was an actual ship right here. It's gonna be a little annoying. Let me put that there. What you can do is you can draw another set of north, south, and east coordinates right there. Draw your, another compass type of region right here, okay? And as you're doing that, I actually get a nice little triangle here. This is gonna be perpendicular to what I have already, okay? Try to make that a little bit darker, right? And here's the deal, okay? Looking at these directions here, I wanna find that angle, right? Does that make sense? Because that's the angle I'm going to use, because this is my north and south line, that I'm going to use to go back to where O is, okay? That's what I want. From A to O, what's the direction going to be? Okay, does that make sense? So now to find this guy, notice that we have a nice little right triangle here, huh? So if this is 22, this is 90, what's this have to be? 68, right? Yep. Okay, so now we have the angle. Now the bearing, that's where this little makeshift, little north, south, east, and west that I got going on here. Okay? So I can tell that it's gonna go 68 degrees, and we're in the what, southwest direction, right? Does that make sense? So let's go ahead and write that down. So south, 68 degrees west. So if you were to, and we're gonna do another example where we're gonna have to look at something that's not at the origin here. But if it's out, away from the origin, create like a new set of axes, find the angle measurements, and then figure out what direction you're heading in, okay? Yes?
Question.
Answer.
If we take ray OA
Mm-hmm.
and then draw, like if you continued the ray out past O as if it was a straight line,
This one?
and then make an angle from say point D to S, would that work too?
So you're saying doing this?
Like that, and then
Okay.
the angle, not there, but yeah, but the other one,
This one here?
yeah, that, is that the
Okay.
same angle?
As, come up to
As
here?
A to O, like,
From A to O, is that the same angle from this to here?
yeah.
It would be. It would be,
Always?
because here's the thing, I don't wanna say always. Only reason why is it depends on what's happening out here. But this and this would be parallel lines, right?
Yeah.
That's your transversal, so you would have a set of alternate angles there. So that can work, absolutely.
Okay.
Again, I don't wanna say always just because there's always that one case that it might not work. It's just not coming to mind right now for me.
Alright.
But it's a cool way of thinking though.
Yeah.
Any others? Okay, let's try another one of these. Now this time, I'm not gonna provide a picture, so we're gonna have to draw the picture first, okay? It's not hard to draw it. So we have a plane, leaves an airport, heading south 40 degrees east at 250 knots. And what that means is that we're talking about nautical miles per hour. If you don't know what knots means. Determine the number of nautical miles, which we'll abbreviate NM, south and west that the plane travels in 1.4 hours. And then we're going to round to the nearest nautical mile. Okay? So we have a bearing. We know the speed that we're going in, and we know the time. So we're trying to locate its position a little bit differently. We want to see where is the plane south and west of the airport. Okay? So yeah, let's draw a picture. Okay? I mean, it's a lot easier to organize your thoughts when you have a picture. Let's do it. Okay? Now, south and east. So I'm going to be in this quadrant here. And I have to measure it from the north-south line, and we're going 40 degrees. Okay. So I'm going to, again, it's just a rough little picture. But let's say from here to here, that's 40 degrees. Okay? It's not going to be closer to the x-axis temporarily, if you call it the x-axis here, because, well, 40 degrees is not too large. Okay, so here I'm going to put point P, and at the origin I'll put A for airport. And what the problem wants us to figure out is following. How far south did it go? How far east it went? Okay? That's what we're trying to figure out here. Oh wait, did it say west?
That was my confusion too. 'Cause
East.
mean,
Sorry.
like, how could it go faster?
It's a magical airplane.
Schrodinger's plane.
Maybe it's negative.
Schrodinger's plane. It could be, it could not be. Just open the box, but you can't open the box. So what is it? Okay, so south and east. So right here, based on this little dotted line, and we have the south line here, I have a right angle, okay, and I have a triangle here. So with right triangles, I can use a little bit Pythagorean. Well, I can use Pythagorean theorem, but I can use some trig to figure out some measurements. This measurement we do have. It's just not specifically stated yet. If I want to find the distance from here to here, we know just from prior math that distance is equal to your rate times your time. Okay. Well, my rate is 250 nautical miles per hour, and then the time is 1.4 hours. Okay, this is per hour. So if I multiply these two together, boy, that is really messy. There we go. I can get the distance from the airport to the plane, which is what I need. I'm going to need that measurement to find the number of nautical miles south and east that they're heading in. So when we do that, we get 350 nautical miles. This is 350. Okay, so far so good. Now, to find the other measurements, doesn't matter what you call them. I'll call this little a, call that little b. Again, any variable you'd like. And let's solve for those. So let's look for a. What trig ratio could I use to solve for a? Sine, cosine, or tangent?
I would use.
Yeah, I would use sine, right? This is your opposite, that's your hypotenuse. So yeah, let's do that. So to find a, we're going to do sine of 40 degrees equals a over 350. So multiply both sides by 350. Please be careful, make sure your calculator is in degree mode when you're doing this stuff. And we get approximately, because we're running to the nearest nautical mile, 225 nautical miles. Okay? And this is in the east direction, so we're going to put east next to it. So that's how far it traveled east. Now, how far did it travel south? Well, let's go back to trig again. What trig ratio could I use to solve for b?
Cosine.
Yeah, cosine, because that would be your adjacent over hypotenuse. I would advise not to use tangent. Even though we found a, again, it's a rounded answer, right? If we keep using rounded answers to find other answers, it's not going to be as accurate. So we're going to ignore that and just use the initial problem setup. So we're going to have cosine 40 degrees. So we'll put here to find b. It's going to be equal to b over 350. And as you can see, I'm going to be multiplying by 350 again. And round to the nearest nautical mile, we get 268. And this is south. And there we go. Okay. And I gotta change my notes to say it was not west, it was east. There we go. Any questions on that? Sound good? Okay, last problem. Now what I'm gonna do is this plane that we're gonna see, or actually not plane, boat, is going to go in multiple directions. And we're gonna see if we can't trace its path, okay? Here we go. So we have a boat, leaves the marina, heading north 62 degrees east at 7 miles per hour.
That's pretty slow.
After 1 hour, the boat makes a 90-degree counterclockwise turn, heading a new bearing 37 degrees west. If the boat travels this new course for 3 hours. Okay, I got 2 things I gotta ask you. So the first thing is, you wanna find the distance from the marina to the boat. That's the first thing we're gonna do. And we're gonna round to the nearest 1/10 of a mile. So that's our first question we're gonna answer. Our second question is to a 1/10 of a degree. We're gonna find the bearing required for the boat to return to the marina. Okay, so those are our 2 questions we're gonna answer. And I'm gonna put all the work on this board, because I'm not gonna try and squish it underneath there. Here's the deal. I know that the boat is going northeast, and then after it's going northwest. So I'm gonna kind of stick with drawing it this way to where we know it's mostly gonna be on the top. I'm not gonna draw this fully out underneath it because it's not going south at all. Okay. And what we're gonna do is just kind of read the problem line by line and try and see if we can't trace its path. And then once we have a trace, then we can start finding some of these answers. So let's do that. So the first thing you notice is that it's leaving the marina. So we'll call this point M for marina. And 62 degrees. Okay. So again, I'm gonna try my best with this. Let's say here. Okay, so from here to here, we'll say that's 62 degrees. Okay, remember you're measuring it from the north-south line. So it stops somewhere out here. Okay? Now, at this point, make that a little bit smaller. Okay, it's gonna rotate. It's gonna go 90 degrees counterclockwise. So imagine this eraser's the boat. So here it is. So it's gonna turn 90 degrees, and then it's gonna go in this direction, northwest 37 degrees. Okay, it's gonna do that for 3 hours. So again, just to kind of visual, so here, turn, and then this direction, okay? Now how do we draw that? So remember in the example down here, I drew my new north, south, east, west lines? I'm gonna do the same thing here, okay? Just like that, okay? And let me, just to have it there, not that we need it. And we're going 37? Okay, so 37 degrees, I'm gonna try my best to mimic that. Okay, and we're gonna go all the way, this, oh jeez. Try that again, that was bad. And traveling it for another 3 hours that direction. So 37, did I say? Yeah, 37 degrees. And then this is 90 because it rotated 90 degrees. So the boat's somewhere over here. So B for boat. Okay. So there we go. There's our picture. So now we got to figure out the total distance. So the total distance would be from B to M. So let me just go ahead and draw that line. Okay. Now here's the good news. I actually can figure that out using Pythagorean theorem. And here's how I'm going to do it. I could find the lengths of these guys using the information they provided here. Okay, so for instance, and I need a point there, let's call that A. We'll call it point A. So to go from M to A, okay, it was what, 7 miles per hour for 1 hour, right? Okay, so my distance here, I'll put it from, well, let's put it over here so that way it's not too jumbled up, is gonna be our 7 miles per hour times my 1 hour, so 7. So it traveled 7 miles here. Okay? All right. Once it makes its turn, it's still going the same speed, but it's going it for 3 hours. So from A to B, okay, so it's still 7 miles per hour, but it's doing it for 3 hours this time. So this would be 21 miles. That's where it goes. So this would be 21 miles. Okay? So now that I got 2 legs of this right triangle, I can solve the third one by what? Do a little Pythagorean theorem. So let's do that. So we have, I'll rewrite it out. So this is going to be mb squared is equal to ma squared plus ab squared. Okay? So let's plug some numbers in and see what this gets. So we get mb squared equals 7 squared plus 21 squared. Okay? So we do that, we get the square root of 490. And we get roughly 22 points, what's it one, nearest 10th. Okay, so 22.1 miles. So there we go. There's part A, all finished for us. Okay, now, part B. We want to know what direction the boat has to head in to make it back to the marina, okay? So obviously, if we think about it, boat's this way. So the boat has to make some turn to make it back to the arena. And how I'm gonna do that is I'm gonna draw my new north-south lines here. Okay? And, well, I think you can see it. This is what I want. Okay, I'm gonna call that alpha. Okay? But I want to know what's that angle measurement gonna be for me. Okay, once I have that angle measurement, then I could say, oh, the boat has to head, and this would be what, southeast direction, has to head in the southeast direction, that many degrees. So how do we find that angle? There's more than one approach to it, okay? Here's what I'm thinking though. If we can find the angle of this whole, like, part of the triangle, because it's not, the whole thing's not all 62, there's that little space right there. So if I find the entire angle there, that can help me figure out what this little guy is gonna be, okay? So let's figure out what this angle is. And I got space underneath here. So using this triangle, okay, I know 2 of these measurements. If I wanna find this angle, that looks like a tangent, doesn't it? That's opposite, that's adjacent. So let's use tangent to find angle M, the full angle M, okay? So this is part B. So tangent of M is equal to 21 over 7. So we're going to use the inverse of tangent to figure out what that angle is. So here we go. M is equal to the inverse of tangent, 21 over 7. And we get approximately 71.6 degrees. Okay? So I'm going to pause for a moment. Any questions so far on the setup and what we've done? The picture is key, I will say. Drawing at least as accurate as a picture as you can help with this. So this entire angle, let's use blue, is 71.6 degrees. Now, here's the nice part. This north line is parallel to the boat's north line, right? This is like a transversal. So these are gonna be, I'll put in red, these are like alternate angles. These are gonna be the same measurements. So to find this measurement, I just gotta what? Subtract these 2 numbers, right? And then I got what alpha is gonna be. So let's do that. So to find alpha, we're gonna take our 71.6 degrees and subtract 62. And we get 9.6 degrees. So again, I'm using, and I'll put that here. alter exterior angles. That way we can kind of see like, why am I doing that? Because again, this is parallel to the boat's north and south line. So now we need a direction. And looking at the red dotted lines I got here, this is the south direction, this is the east direction. So the boat has to head south 9.6 degrees east for that guy. Okay? There we go. That, my friends, is some applications, some trick stuff, which is kind of cool. There's more, actually. Okay, this is just the intro. We're going to do law of sines, law of cosines, which those are some really interesting problems there as well. So, any final questions? You guys are awesome.